Hello everyone, today I'm going to talk about the first video in my series of the fault analysis videos, and at this video I'm going to talk about the 1x fault analysis. 1x is a very common pattern you can see in the vibration spectrum, and it's the most difficult pattern to be diagnosed because 1x could mean many things. Could mean unbalance, eccentricity, bent shaft, excessive clearance, even soft foot. And we're going to talk about the unbalanced fault, and also we're going to talk about all these types of faults in the series of the fault analysis. But yeah, let's start with the unbalanced fault. My name is Salah Ataya. I'm a condition monitoring and reliability specialist. I have a bachelor degree in mechanical engineering. I'm level 4 vibration analyst, level 2 in machinery lubrication, level 2 thermographer, and level 2 in asset reliability. Uh, First, let's start to talk about what is the unbalance. When the center of mass start to be away from the center of geometry, so it start to cause driving force that wears the machine fast. And this forcing frequency appear on the vibration spectrum as a component at 1x with a high amplitude, with no harmonics or with very little amplitude harmonics. And what is the balancing, which is the against meaning of unbalance? Is balancing is the act of adding or even removing masses from or to the rotor in order to reduce the effect of the 1x vibration levels. We have many causes of unbalance. It could be like eccentricity or shaft bow or corrosion and wear, or even build up material like like dirt in the cement industry, or even thermal distortion. It can happen like in steam turbines or big rotors. We can see here on the photos like corrosion in blades or lost in blades. This could be a real cause of unbalance. What's the unbalance type? We have different types for the unbalance on the rigid rotors. Like we have a static unbalance, and this happens when the center of mass is away from the center of geometry with eccentricity, what we talked about before, and the center of mass is parallel to the center of geometry. We can see here the heavy spots almost at the same location at the two planes. In the couple imbalance, you have the center of mass not parallel to the center of geometry, it's inclined on the center of geometry, but they intersect in one point. In the dynamic imbalance, which is a combination between the couple imbalance and the static imbalance, you have the center of mass, it's not parallel, and also it is not intersect with the center of geometry, and this is the what we call dynamic imbalance. The first type of imbalance we're going to talk about is the static or force imbalance. In the static or force imbalance will show as a high amplitude 1x on the vibration spectrum on the radial direction, and the vibration amplitude will increase by the square of the speed below the first critical speed. Imbalance can be corrected by single plane balancing job. You can see the fan drive end and the fan non-drive end are in phase at both horizontal and vertical direction, which means if you use a tachometer and you put the tachometer on the shaft and then you use two sensors, one on the drive end and one on the non-drive end, and both in the horizontal direction, and you measure the amplitude and phase, you will see that the phase degrees or the phase angle on the drive end very close to the phase angle on the non-drive end. There might be some difference between like 10 to 20 degrees, but they will be in phase. Same as in the vertical direction. If you move your sensors from the horizontal position to the vertical position and you measure the phase angle in the drive end and non-drive end, you will see that the machine also in phase on the vertical direction. And when we correct this, we do single plane balancing job. The couple imbalance, it will also show on the vibration spectrum as high amplitude 1x on the radial direction. But in this case, when you're trying to correct the imbalance, you will do it in a two-plane balancing job. The fan drive end and the fan non-drive end will be out of phase about 180 degrees in both horizontal, as you can see, and in vertical as well. Also, when we talk about the horizontal to vertical direction on the same bearing or on each bearing, you will find that the phase difference is about 90 degree plus or minus 30 degree, same as the static imbalance. Dynamic imbalance is very similar to the couple imbalance. We here will see as well horizontal at both drive and non-drive will be out of phase about 180, vertical will be out of phase at 180. The phase between horizontal and vertical at each bearing by itself, it will be about 90 degree plus or minus 30 degree. It can be corrected by two plane balancing. For overhang machine, an overhang imbalance will show as high amplitude 1x, but at this condition it will be in the radial and the axial because of some gyroscopic moment will happen on the fan impeller on the axial direction. And Very important thing that if you measure the phase at the axial direction at both the drive and non-drive end bearing, it will be in phase. If the out of phase, it will be mostly or more likely as a bent shaft. The drive end and non-drive end, they might be in phase in horizontal and in vertical, or might be out of phase, and this will decide if you go for single plane or two plane balancing job. If you go for H bearing, you will find this bearing is the, the phase difference between horizontal and the vertical about 90 degree plus or minus 30 degree. A good recommendation when you unbalance need to be corrected, it's really need to be corrected because it's destructive effect, it have its destructive effect on the machine. It will wear the machine, the fatigue force will affect the bearing, and also will affect the coupling and will affect your motor or the drive machine. You need to be sure that the problem is unbalanced before doing any correction. In case of having high vibration at both motor and fan sides, the action is to run the motor uncoupled. Like for example, if you have a motor and a fan and you find that you have high vibration at 1x on the motor and you find this vibration at 1x on the fan, but the vibration levels on the motor are higher, so it could be problem with the motor itself, like the cooling fan is broken, or soft foot, or excessive clearance, or even the motor itself have imbalance. To be able to decide if the problem from the fan or the motor, and to be sure it's not residual imbalance in the fan and transmitted to the motor, decouple and run the motor by itself as a solo run. If the vibration levels exist, so you be sure it's from the motor. If not, it might be from the fan. And anyway, if you want to correct it without sending the motor away to the workshop to do balancing for the motor, you can balance the whole system from the fan side or from the impeller side of the fan. And also if the fan and the motor like belt driven, the same condition, you can remove the belt. Be careful when you measure 1x on the motor and fan and it's belt driven, you will find two 1x, 1x for the motor and 1x for the fan, because the speed is different. And when you do balancing, be sure that you put your reflective tape on the fan shaft, not the motor shaft. Check the fan impeller condition for dirt buildup or cracks before you start doing the balancing job. I'm gonna to make a series of videos about just the balancing procedure itself, the practical side, how you do it on site, how you mark the plates, how you put your reflective tape. Everything will be recorded from a real balancing job from site. And as well, it will include all the equations and the equations of how to estimate the trial weight. Thanks for watching the video. Please like, subscribe, and share. And yeah, that's all. Thank you.